welcome to our second online discussion for the exhibition Interfacing New Heavens. We convened today for a conversation between the artists participating and their respective collaborators from the field of astronomy, who they interacted with during their Residency Exchange in 2018. We are greatly appreciative that Nicolas Billot and Julia Seidel from the University of Geneva, as well as Daniel Cunnama from the South African Astronomical Observatory could join us today. This conversation forms part of the public program for Interfacing New Heavens, which is titled "And Other Necessary Fictions 2, Propositions for Future Possibilities." Nicolas Billot is an astronomer and associate scientist at the Exoplanets Group within the Astronomy Department at the University of Geneva. As an operations scientist of the CHEAPS satellite that was launched in 2019, he's in charge of producing the sequence of observations that CHEAPS will be executing on board with the aim to study extrasolar planets. Julia Seidel is a postdoctoral fellow at the University of Geneva, mainly working on observations and modeling of exoplanet atmospheres. Her current research aims to learn more about their structure and cinematics via nested sampling retrieval methods. In 6 weeks, she will be moving to Chile, where she will work for the European Southern Observatory within the Perennial Observatory. Daniel Cunnama is the science engagement astronomer at the South African Astronomical Observatory, where he is tasked with promoting the SAAO and their various initiatives. Daniel received his PhD in astrophysics from the University of the Western Cape in 2013. He's the creator, producer, and host of the Cosmic Savannah podcast and features regularly on television and radio. He has also produced planetarium films focusing on South African astronomy and indigenous knowledge. Tebogo Mahashe works in the field of photography, particularly at the intersection of artistic practice, archives, and anthropology. His research takes Kelebedu as a central idea, drawing on its capacity for complicating ways of knowing and encouraging transdisciplinarity. His current research project, Defunct Context, engages a synergy between art, science, technology, and indigenous knowledge systems. The artist and researcher has a PhD in fine arts and lectures at the Michaelis School of Art at the University of Cape Town. Trained as an industrial design engineer and media designer, Vanessa Lorenzo critically engages with technology through her artistic practice in order to enable art sympathies among people, the environment, and the technologies that intertwine them. Based in Lausanne and Berlin, she has participated in residencies, public events, and exhibitions internationally. Vanessa develops public workshops that focus on the production of new knowledge through biopractices, DIY open source electronics, and speculative design methodology. We welcome our panelists today. Just to notify the audience also that this conversation is being recorded. I will now hand over to my co-curators, Erin Heidegger and Florence Fisher from Artists and Labs, to give more background on the program. Welcome.
Thank you very much, Sinetemba, and welcome also from my side to everybody. And thank you for tuning in tonight. My name, as you heard, is Erin Heidegger, and I'm the head of the Artists in Labs program and one of the co-curators of Interfacing New Heavens exhibition at the Javits Center in Pretoria. The exhibition will share works and processes that emerge from a long-term conversation and exchange that started back in 2018 with the 3 months Artists in Labs residency of Vanessa, Lorenzo, and George Mahashe, and of course the astronomers that were just presented to us both in South Africa and in Switzerland. And I will now just give a short background on the Artists in Labs program. For those who don't know it, our program is located at the Zurich University of the Arts in Switzerland. And this university offers various degree programs within the arts, spanning from fine arts, theater, dance, music, art education and design, to even a master in transdisciplinarity, and of course also indulges in research in the arts with also postgraduate programs. Within this sphere, the Artists in Labs program has been facilitating forms of artistic research by way of these long-term research residencies for artists, and is located then, or is conducted in scientific laboratories and research institutes in Switzerland, but also worldwide. Our motivation to bringing scientists and artists together for over a decade now is to really critically engage with our contemporary world and the challenges we face on many levels today and also in the future. We also create, we really also like to create opportunities like this one tonight to share and exchange and get into an extended dialogue, of course. The very nature of crossing disciplinary boundaries and engaging with each other means really to be open and to accept a certain level of non-understanding from both the artists and the scientists. And also it means entering a place of not knowing together. Last but not least, it takes the generosity of sharing beyond disciplinary fields and knowledge systems, and the drive to raise questions that might not anymore be asked within the confines of disciplinary boundaries, be it in the sciences or also in the arts. And with this in mind, let's look back to 2018 before we get into hopefully vivid Q&A session.
Thank you very much, Irene. Hello, everybody. My name is Florence Fisher. I'm a research associate at the Artists in Labs program, and I'm also a co-curator of Interfacing New Heavens. In spring 2018, an open call was issued in South Africa and Switzerland, inviting artists with an interest in astronomy and transdisciplinary collaboration to submit a project idea. After an extensive evaluation process, a jury chose 2 artists to participate in the South African Swiss Residency Exchange. In autumn of 2018, the artists Tebogo, Mahashe, and Vanessa Lorenzo participated in these 3-month Artists in Labs residencies. Vanessa at the South African Astronomical Observatory, SAAO in Cape Town and Sutherland, South Africa, and George at the Astronomy Department at the University of Geneva in Switzerland. In the first week, they both presented their ongoing artistic practice, their motivation and interest to work with astronomers, as well as their project ideas to the science community. Both artists were then engaged in a daily transdisciplinary exchange with researchers and had access to most of their infrastructures and resources, such as databases, workshops, or libraries. They were also provided with a studio space and were included in the daily working rhythms and routines of their respective institute. During this research phase, both artists developed a prototype for an artwork, which was presented to the science community and the public at the end of the residencies. And now I would like to hand over to the first of our panelists, to Nicolas Billot, who will give us a short insight into his research.
Thank you very much, Florine. So yeah, I'm gonna just try and explain really briefly what I'm working on these days. So if I may just share the screen, I have a few pictures to show you. Okay, so this is the starting point, right? I mean, this is the night sky, I think most likely taken from South Africa. This is at least what Google told me. And the thing is that all the little dots, the bright dots that you see in the sky, I mean, all those are stars, right? So they are like our own sun, except that they are like far away. And as it turns out, about, every other star has at least one planet orbiting around it. So you can imagine so many points in the sky, so many stars, it's billions and billions that have actually planets like similar to the Earth, to Jupiter, and all kinds of planets orbiting these stars. So it's just that the universe is full of alien worlds. And this is fairly new in a sense, this knowledge about the amount of planets that we can find in the sky in the universe. So, I mean, obviously that got people interested, and you know, curious people would think, you know, what are these worlds made of? You know, what's happening out there? And the idea is that on the ground or in space, we have astronomers putting tools, you know, on spacecraft or on the ground to observe these objects and, you know, try and understand and characterize what these objects are made of, basically. So this brings me to CHEOPS, and Sinetemba mentioned this. This is the, you know, my pet project. This is what I've been working on for 5 years. This is basically a space telescope. So this is like a picture of what it looks like. It's pretty much like a, you know, very large washing machine that we actually put in space. So this project was put together by the European Space Agency and a consortium led by Switzerland. So to the left, I put, you know, all the logos of all the partners that we have in this project. It's quite a few. It's actually 11 countries, and all together we made this work. So CHEOPS actually stands for Characterizing Exoplanet Satellites. So the goal of CHEOPS is really, you know, in a sentence, to measure the radius of planets that are outside of the solar system. This is really what CHEOPS is made for. So this was actually launched in, you know, just a few days before Christmas in 2019. I had the chance to be there, you know, to attend this event. It was brilliant, amazing, an amazing experience. This is what it looked like from very close. And this is like just a picture I love. I mean, this is basically the trail of the rocket booster piercing through the clouds, above the cloud, and then it goes on and on and on, and eventually released the spacecraft. So this is beautiful. I mean, it was a rainy day, a rainy night, clouds and rain, but it was beautiful, really beautiful. And we had a lot of fun. People were just, it was a moment of pure joy, basically, pure happiness, as you can see on the faces of people. And since then, so it's been a year and a half. So CHEOPS is basically, you know, it's the telescope that we put on a spacecraft, and now it's orbiting around the Earth at about 700 kilometers above our head. It's not very far. We call this like a near, you know, like a low Earth orbit that we're seeing. And so you see basically this satellite, the sun is to your right, and the pointing of the telescope is basically always to your left, you know, to the dark side. And so this is what it looks like. Of course, the spacecraft is not as large as this. The scale is not to scale compared to the size of the Earth. And yeah, so this you know, tells you a little bit what it looks like. And here in Geneva, what we do. Oh yeah, maybe let me mention exactly what we do with this CHEOPS. I mean, with this telescope, what we do is that we pick a star around which we know there's a planet, and we stare at this star for hours, possibly days. And what it looks like is basically, you know, this weird shape. We call this the PSF. This is pretty much how a star looks like when we look at it with CHEOPS. And so what happens is that, you know, if you have a star that looks like the sun, possibly, and if you have a planet that goes in front of it, that this makes like a miniature eclipse, basically. So what you see here on this plot, it's really simple. Basically, if you stare at a star, the light that you receive from the star is pretty much constant, you know. The star is quiet, you just receive an amount of light. And when the planet goes in between the star and the telescope, the amount of light that you receive is slightly lower. And this dip in what we call the light curve tells you what's the radius of the planet, pretty much. So this is the very basic principle. And this is one of the first results that we published less than a year ago. So the telescope is working beautifully. Scientists are ecstatic about, you know, the quality of the data. This is brilliant. We have so many papers coming out these days. So this is really, for now, so far, a success story. And I want to mention maybe what we do in Geneva. So my role is basically doing, I'm called the mission planner. And in other terms, it's most likely, you know, like I'm the pilot for CHEOPS, if you wish. So this is all about, you know, making the telescope do what you need it to do. So I don't, maybe not going into the details, but yeah, this is it. This is the small team we're working with, because in the end, it all comes down to people, you know. This is, we are running the spacecraft and, you know, collecting all this amazing data for the scientists. And as I said, so far, it's been a real success. So this is like in a nutshell, you know, what CHEOPS is about and what I'm doing for CHEOPS.
Thank you very much, Nicolas. Daniel, you would be the next to present us your work.
Great. Let me just share my screen too. So my name is Daniel Cunnama, as I've been introduced. I work at the South African Astronomical Observatory, which is based in Cape Town, South Africa. And our telescopes are based in Sutherland, about 4 hours north of Cape Town, up on a plateau in a very, very dry region. And you can see an image of it here. So we have about 20 telescopes based in Sutherland, and they work on various astronomical research projects. So in the distance is SALT, the Southern African Large Telescope, which looks small in this image, but is actually the 4th largest telescope in the world. And then we have an array of other telescopes, which all sort of focus on different things. So, you know, some of them work on microlensing experiments like we just saw with CHEOPS, and others work on asteroids, some work on distant galaxies, and as well as stars and stellar evolution. So we at the observatory have a wide range of research interests, and as was mentioned at the beginning, it's my role to try and share this science, share this expertise, and then also just share the incredible sort of astronomical projects that are happening in our country, of which there are many and varied. So my work these days, I have moved away from doing direct research, and now I work mostly on science engagement and science outreach. So I do a lot of work in terms of making videos, as was mentioned, planetarium films. I'm working a lot on the indigenous star law of Southern Africa, which we are trying to collect and record and share. And we've got various projects underway with that. And yeah, I think that you know, there's definitely a lot to be proud of. And this is I'll let it play now. This is just a short trailer. Hopefully it works over Zoom for the first planetarium film we made, which was called Rising Star, and that profiles a large part of South African astronomy. So not just the Southern African large telescope, but also the other telescopes around the country and some of the research we do. So this was just an example of trying to capture all of this, which was and try and share it in a planetarium sense. So I think that I'll end there.
Thank you very much, Daniel. Julia, you would be the next person.
Sure. Let me also share my screen real quick. So I also work at the Observatory of Geneva, which is very handy because I directly profit from Nicolas' work. Because what he does is he finds all of these alien worlds for me, and I just sit and waiting until he finds something interesting, and then I jump on it. And the question that I work on is, what are these alien worlds actually? Like, are they, so Nicolas tells me, oh, I find something super interesting that is kind of the size of Venus. And then my job is to decide, well, is it like Venus, or is it like Earth, or is it like Mars, or is it completely different? What is happening on this exoplanet? And for that, I use ground-based telescopes. The ones that you see here, they're in Chile in the Atacama Desert, because from the Southern Hemisphere, you just see a better sky. It's just more interesting. So most of the telescopes, the professional telescopes, are actually in the Southern Hemisphere. And what we do with it is basically just building on what Nicolas explained to you just a second ago, just to revive your memory a little bit. So what happens is the planet moves in between us as the observer and the star that I show here in blue. And while it kind of crosses over it, it produces this mini eclipse. But it's not only that light gets blocked and we get this mini eclipse where we get less brightness from the star, but a very, very small fraction, a part of 1%, also goes through the atmosphere of this exoplanet, so to say, right? So we have the particles interacting with the light in the different parts of this atmosphere. So they might get absorbed, so we don't see this specific color of the light anymore. So maybe it looks bluer, or it looks yellower, or it looks redder. And from that, we can know something about which particles, which elements are there. Do we have oxygen? Do we have water? Do we have something completely different? And also the kinematics of it, like how fast are they moving? Is there storms there? Are there clouds? So these are the kind of questions that I work on. And this is then what the result looks like. So here on the right, you have like a small panel of the actual data. So I get these absorption lines where an element just grabs more light from in the atmosphere, and then I try to fit models to it. And from that, we can actually learn quite something. So we can learn, for example, if we see iron in the atmosphere and we only see it in a part of the atmosphere and not in the other part, then we know something must have happened to this iron. And if we look then at, for example, the temperature, and we know that it went from being very hot to a little bit cooler, like when a storm moves in, for example, then it's quite likely that the iron isn't there anymore because it has rained out in tiny liquid iron droplets. So one of the results that we had last year was that in one of these Jupiter-like planets that Nicolas found for us, it's actually raining iron at the evening, when it's evening. So that was one of the very, very cool results. And this is what not only myself, but obviously the entire exoplanet group in Geneva and in other places work on.
Thank you very much. And now we hand over to our two artists. George, would you like to begin?
Yes, thank you very much. I'm going to share some images. These are sort of just snapshots of some of the moments. I think for me, it's how I end up here, right? Is I had a dream of a water planet in a particular region of space. And from that dream, I sort of, ended up applying. But from that dream, I was able to start asking very specific questions that, for me, looking at the different institutions and the different groups that were available for me to interact with at the University of Geneva, I found myself wanting to be with the exoplanet because, of course, it's a water planet. The idea of a water planet in a dream might sound strange, but I am a very big fan of this is not the greatest image. I'm a very big fan of a South African thinker, healer, Credo Mutwa. And Credo Mutwa, in his discussions of South African star law, speaks of knowledge of 11 water planets and goes into details about what these planets might entail. And then on top of that, for me, there's the star law. At the same time, there's also the question of how does one imagine how one can come to this knowledge. So for a lot of people, when we think about star law, when we think about the knowledge that Southern Africa has of the heavens, which is quite vast, and most of it predates the modern telescopes. We take for granted how these knowledges might have come through. And for me, what was interesting about dealing with Credo Mutwa, who, he talks about a whole lot of things, some of them controversial, some of them very critical. For me, was he kept talking about the importance of instruments. One of the first things that really got to me was his discussion of a microscope that healers used to use to perform surgeries, which for me obviously was quite mind-boggling. So for me to think about these type of technologies, the only way I can access it is ultimately through photography, which is my main field. And from that, I was fascinated by the camera obscura, which I took with me to the observatory. So the first thing I did was to build a camera obscura looking at their domestic telescope, which is quite small. And very early on, I understood that I wasn't going to look at the stars. One of the other things that I did was tried to look for similar narratives within Europe. And one of the things that really fascinated me, I'm obsessed with copper, was conversations of this shaman from Siberia. And he's got all sorts of copper implements on him. So for me, I started thinking about the instruments that different types of specialists, because for me, when I think about Dingaka, I'm not thinking just about a healer in the domestic sense, but I also think about specialist people that devote a hell of a lot of time to thinking about instruments. And for me to be based at the Geneva Observatory, which is one of the spaces where they really take the idea of instrumentation seriously, meant that I could think and start to bring myself in line with, if one wants to, start thinking about how we come to know these things, how do you recover a sense of capacity for making these instruments? And I'm going to flash this image, but you can always pause later. And for me, this is one of my first ideas that came on paper. And then, the ideas kept moving. At the same time, I spent a lot of time looking at the journals, the papers that were all over the observatory. I also spent a lot of time in their junkyard, where they threw some very, very, very high tech, well, for them, it wasn't high tech anymore, but some really, really cool optical instruments. Of course, I'm interested in optics. And from there, I started thinking about how the one stuff could become something else. Like for me, I had to straddle the space between a mythical object or an artifact that's traditional and trying to really make it scientific, which is how I started the approach. At the same time, I was looking at Credo Mutwa's necklace of mysteries and the different things that were on it as a way of thinking about how I would approach this. At the same time, I was also really thinking about a story of a diamond that had been used as a sort of lens that was used in the process of reading stars. So, I started with all of these things and ended up here. So I'm going to stop here to share. I just want to see what's down there. And of course, this is what would eventually come out. They would, I'd speak with the technicians and they would help me make an object that sort of tried to see through what I had. And then obviously I was there at a time when they were working on a particular type of instrument, and I got to speak to the optician about it. And of course I was working on type of, for me, it's not about big scale, but for me, one of the things that was important was how do I start thinking in this way? It's not about creating a realistic telescope, but it is about how do you recover a vocabulary for thinking about, if you were to make instruments, how would you approach it? So I think for me, I will stop with the images here. what was interesting for me, which I think is the most important thing that I took away, and it goes to the two scientists that I've sort of wanted to be in conversation with today, was the centrality of conversation. So for example, in my lunch conversations with Nicolas, we'd basically talk about all sorts of things. And one of the important things has always been that question of always being faithful to your perspective and the way that your creativity process work, which I think for me was quite an important conversation to be had. And at the same time with Julia, who's a little bit my age, we engaged in a whole lot of other conversation. And one of the most interesting conversation was when I was trying to think about how these specialists used to basically read the atmosphere as a form of observatory, was the way in which she would always be able to say, okay, so this is what you're thinking about. While this might be a problem for science, this is how it might actually function. So we'd have conversations about telluric interference, which for me has been a very productive way of thinking about some of the concepts that I have. And on top of that, one of the other things that was quite important was the type of social engagements that we hung out a lot, we had lunch a lot, we went to karaoke every now and then. For me, what was always fascinating was how the scientists were always in conversations with other people all over the world. And for me, that aspect of conversation was a very important thing that also took me back to what within the process of making art was a generative process for me. I've never been an artist that works in solitude. I've always been a person that talks a lot, which is why I end up in the academy. So for me, I think in my gravitation towards the sciences, there is the question of the cultural knowledge, which I don't think today doesn't want to come out. There's that concept which sets me up to be in conversations with some really interesting things that are happening in the contemporary. And I always like to say that, when we think of the ancestors, for me, I think where my ancestors are alive today, or as they are alive today, they would definitely be at some of the world's most, premier institutions. And for me to find myself in such institutions, having conversation ranging from, cosmology all the way to the most technical aspects is something that I think needs to be thought about more broadly. But at the same time, to be reminded that the only way knowledge is produced is through some form of and I'm also happy to see that a lot of people that I consider my regiment are in the room today. And Bohuera for me is a particular type of relation. It's loosely translated to friendship, but there's a way in which a professional friendship that's rooted in real friendship and conversation becomes important for how we come to expand the way we think. And for me, that's what that dream kind of led to. So I think let me stop there. Yeah, I'll stop there.
Thank you very much, George. Vanessa, can I hand over to you, please?
Hello, everyone. I'm gonna share my screen as well. So my name is Vanessa Lorenzo, and I took part on the South African side. 3-month residency back in 2018. And before I applied to the program, I already had the curiosity of this intersection between disciplines. I studied industrial design, and it's itself a transdisciplinary way of building objects or applications or services. And from that, I started more and more introducing my practice into the artistic world through installations, interactive objects, and using new digital media. And at some point, I moved to Switzerland in 2014 to study my master, but I also encountered a country, but also a culture that values scientific knowledge a lot. And there's, I encountered also different scientific groups or associations through which to experiment science differently. And from my design and art background, I felt pretty privileged to start asking myself questions about what kind of questions would people ask if we all could have access to scientific tools or telescopes or laboratories. I want to show you an image. This is in Valais, in a region where we have a little hut, and we go a lot with friends. And I encountered a book about legends from this region. And I started a project thinking about rocks that would fall from the peak to the plateau where the cities are. And these rocks will carry memories. And I started building an installation or prototype in which when you get closer to the rock will start talking and telling a story. Or when the light of the room will dim, the rock will also start a conversation. And later on, I also worked with scientists who built an open source fluorimeter, which is similar. It works with spectrophotometry. And this sensor can measure the light that comes out of a fluorescent body. And yeah, this also led me to work with what you can see in the image is a water sample from a river in Valais, in the region that I previously showed you, and which got contaminated with mercury and the 30s, 40s. And in 2015, people discovered that there was a huge contamination of this heavy metal. And I found a way to put the scientific tool inside a camera oscura, through which the people could see samples from different periods, from the early 30s to the 2017, where the project was presented. And each sample had different concentration of mercury, and therefore different concentration of fluorescence. And when the people came and see through the hole, they could see a non-spoken dialogue between two artifacts, the mercury and this fluorescent bacteria, which I didn't mention before, that reacts to mercury. So there's two artifacts, two strange bodies that there shouldn't be in the river. And thanks to this tool, they can talk to each other and tell another story that the humans are not able to tell, which is that we don't know what to do with the Anthropocene or the polluted environment or planet that we are inhabiting. And I think that these two projects, which are totally different, but they all talk about non-anthropocentric storytelling and through an object that is interactive. And this led me to apply to the Artists in Labs program in 2018. And I was lucky to go to South Africa and developed Always Calling Home, the first prototype, which is based on working with asteroids and near Earth asteroids, which are rocks that are floating or wandering in space, or rocks or mini planets, let's say. I don't know where to put the limit. I guess it depends on the size. But for me, they were matter rocks that also carry memories from those planets and billions of worlds that Nicolas was telling before, no? When he showed the picture of the Milky Way. And so how to make them speak those memories, that was one of the questions that I had in mind. And when I went to South Africa, I had the chance to be supported and mentored by Daniel Cunnama and also the fellow scientist, Dr. Nicolas Erasmus, who is working with characterization of near Earth asteroids. I was lucky to learn more about this tool, which is, I don't know if you can see it correctly, but so here you can see the installation and I don't know if you can see, but here there is a video of there is a video of one of the meteorites. Maybe it's better to see it like this. So if you can see the meteorite is in the middle. It's a little point that is more or less fixed in the screen, while the whole stars are running behind. So the telescope is fixed on this point and is getting data from 3 different filters. So it's getting light in different wavelengths and different colors. And this is how and this is my point of view completely. For me, it's like, this is how scientists can listen or understand what the asteroid or the asteroid has to say. If the asteroid is fast or is slow, or is made of iron or gold, or is full of water, or is one shape or the other, the orbit. And yeah, for me, that was the starting point of something, or of trying to communicate in a modern human language. And yeah, so after that, of course, I was amazed by like being able to be in the middle of the desert and the Karoo Desert, and listening to all these stories of the first people that inhabit this this desert and how they communicate to the stars, with the stars, and how stargazing was so important to them. And by chance, I was talking to the people living there all year round, and they told me about the site in which you could play with the rocks. You could take a little rock and hit a big rock and listen to different sounds. And so I heard a story about a scientist, anthropologist studying rock gongs in the area, and how these sounds are also linked to the language that is spoken in this region, and how it's so, like, it could also the resonance of these rocks in the environment was also a tool to, for example, guess if the ground was dry, and how the cavities would resonate. And for example, if the rain will come soon, and it was time to move. And I became super curious about getting to know more about it and how to translate this into an interactive installation. Not because I wanted to do something interactive no matter what, but because I wanted to work with a non-human language and noise, which is not melody, it's not music, it's not spoken lyrics, a song, but noise allows to speculate with new ways of telling stories. And therefore, I took the data from Nicolas. He helped me to translate it into different frequencies, and I made a little playlist. But I don't know if you can hear. And this would be the asteroid being tracked while it's turning. It's a very raw noise, but it doesn't matter. With this, I could already start building a language, or a sort of interaction between the asteroid and humans through this medium. Yeah, so along the way, I learned different ways of programming or translating this data into sound. And also I wanted to work with the asteroid, but obviously it was a little bit difficult to bring them to Earth. So I worked with the rocks, and this was at the beginning my very humble way of characterizing them, like number them with post-its and photographing, making photographs and measuring them, choosing the colors and the shapes, and how the light would reflect on them. It was very speculative. I didn't know what to do and how to do it. And so I started picking rocks from the desert. And then I was talking to some of the artists and friends that I made in Cape Town. And some of them, I also joined a conversation about territories, the rocks being proxies of territories. And what about not picking rocks and taking them to my studio or even back to Switzerland, but what about asking people to share with me a rock that was meaningful to them, and that carried a story, meaningful story, and they wanted to share the story and the rock with me. And so some of the rocks that you can see are from gardens, from the childhood plays where some of the friends that I made in Cape Town and Johannesburg as well came from. And yeah, so now I think I'm exploring the notion of archipelago, and the way of exploring that for the upcoming exhibition at the Javedah Center is to see ourselves, and I'm collaborating with 11 artists in total, 7 sound artists, and 4 video, sculpture, and also sound and media art, exploring the radical togetherness through the notion of archipelago. We are all in different locations working through the internet due to the current pandemic, and we are working on a new object that would hold life and memories that are carried by a real meteorite. And there is a video about it that you will be able to see very soon, about a speculative DIY tutorial of how to characterize an asteroid and meteorite by leaking the meteorite, and also a DIY tutorial of how to make a terrarium in order to culture the xenolife, the alien life that could potentially be carried by this meteorite. And also we are working on a new collection of noises with this archipelago of artists, and to make a radio podcast that will be streamed very soon through a virtual environment. Okay. Where we are gonna be all avatars streaming this radio podcast with extra sounds and noises.
Vanessa, allow me to make some noise at the moment, because I see time passing. And as we would like to also enter into the conversation, thank you very much to give us, all of you, all the panelists, to give us like such an overview of how you engage in your work and your practices and research. And I would really like to invite everybody in the room to engage in the conversation. If you do have questions, please just ask them, because I mean, there is an amazing number of people on this panel that are probably more than glad to answer all the questions we have, and I'm sure there are a lot of questions around. But I think that you can think of the questions. We will just start with one question to start off like the conversation. But please don't be shy. You can also put it in the chat if you like, but you can also just ask yourself. But if you ask a question, it would be nice also to see you.
All right, actually, I want to start with a question regarding expectations. So I guess it's pretty unusual for an astronomer to have an artist embedded in their working environment and get into like a daily exchange. So Nicola and Julia, what did you expect, or what were your expectations when you heard that an artist would come to your research group and be there for 3 months. And then how did the interaction with George actually start when he arrived? Like, how did you get into conversation?
You want to, yeah, okay, then I'll go first. So I don't know, expectations, to be frank, I was quite excited, when I heard that this was going to happen, to have an artist joining us. And I mean, to some extent, you see, this is, I think having an artist around, it's like a new horizon, basically. And, just having someone new, creative, just, looking through another keyhole, looking at the world, because I mean, us scientists, we obviously look at the world through a keyhole, and we are aware of this and trying to make this keyhole larger. But I mean, I guess the, the perception of the world from an artist's eye is just looking through a different keyhole, and this can only, enrich anything that we create. So, so that was a little bit the expectations that I had. And then when George came in, I mean, I wasn't disappointed. New horizon it was, certainly. I mean, I don't know, it just happened naturally, like someone new came in, friendly. We just start chatting about, what we do, what he does, and what we could make out of it. It was just like, simple and natural. And actually, I mean, I think one of the thing that I liked very much at the beginning when you arrived, George, was this camera obscura. Because I mean, I like photography, and I actually have one of your pictures that you made. This is now, it stayed with me, and this is, like my screensaver. And I love this. This was beautiful. So, I mean, we found like a common ground on, like photography and aesthetics, I guess. And then from there, it went on and on for a few months.
Okay. Maybe I can just add to the question, because the other day there was a podcast that I didn't really have the time to listen to yet, but from Didier Colloq, who is one of the Nobel Prize winners, like 2 years ago. And he was basically presenting himself as a passionate person that instead of becoming a storyteller, was becoming an astrophysicist. So just about like, because I heard now in many of your presentations, like the role also of telling a story, or like there is a story embedded in what you're doing. So can you maybe say something about, maybe addressing to George, about how these stories came together, maybe?
Yes, sure. I mean, to some extent, I mean, storytelling, this is how you put words on, what you see or what you perceive, right? So we all do this, not only scientists or artists. I mean, this is what people do, in a sense. So our stories were, I don't know, I mean, I think at some point, they converged. But I mean, most of the time, this is still like two different worlds. I mean, like the scientists, they have to be like, Cartesian, this has to fit in a box. And to some extent, it's different. I mean, this is the way I feel, that how, artists or, outside of the scientific community would perceive what we do. There's probably like two distinct ways of, perceiving what we try to achieve in science. And as for George, I think when he came in, I mean, he had this, this dream that he mentioned, and this was probably the seed for, his adventure. So in a sense, the storytelling, started from a different seed, but, with this residency, we managed just to, there was an overlap for a time. And so I would say that the storytelling converged at some point, when we were in Geneva. I don't know, George, if that's...
George, yeah, like from your side, because we're coming from a dream in a way.
I mean, look, I think there were many types of stories, because I think when people think about stories, they always think about the mythical. And I think for me, one of the stories that because also there's stories, and then there's when you tell a story that gets answered by a story. Because I think for me, that's how most of the time we interacted. I would tell you a story and you would tell me a story back. And for me, one of the stories that stick, which we actually spoke about yesterday, was this billionaire that wanted to send many micro satellites into space, and we ended up talking about these billionaire tech guys that are actually doing it now. And for me, that story was interesting, because I think at a point I wanted to send a camera up into space in a balloon. And every day I would come with a new story about something that, it would always start with, in the dream I saw X, Y, Z, but it would quickly move away from that and be into something very concrete. And this for me is what's different with some other scientists that I was speaking with, is you would tell them something and it would go straight to the hard science. But there was a way in which, before we went to the hard science, there was a story that would be told back. And over time, the story would lead me or lead us into a space where we could actually move. So for me, there's something about a story not as something told to a passive audience, but something as a story that elicits another story. And for me, I think that's something that happened. And I think these kinds of things are hard to replicate in this setting. But for me, I think that was an important exchange mode of, you tell a story comes back, and slowly but surely it moves out of the mythical into the very practical without losing the thread between the two, which for me, I think is quite an important format. And it's a skill. It's a skill to be able to converse in that way.
Julia, would you also call what you're doing a sort of storytelling? Could you relate to that term in regards of scientific research?
Well, this is actually quite interesting, because had you asked me that question in 2018, I would have said, no, of course not. This is not what I do. I find hard facts about stars and planets. This is what I do for a living. But this has actually quite changed, because what I learned from George being in Geneva was actually not only about how the sky and science relates to art, but also how it's the perfect vessel to talk about science, so that you can use the storytelling part of it to reach a wider public with your scientific results. Like, can seem quite boring, right? I mean, who's interested in whether there's a little bit of a dip in light or not? What does that actually mean? What does that bring for society in a sense of awe or amazement for the night sky and our common global heritage of looking at the stars? So in this sense, all of his stories about the knowledge that has been gathered over many centuries in South Africa about the night sky, and how that has now direct relations to the things that we find in the sky, that was like really amazing, and has led me quite down a rabbit hole over recent years to look into other cultures, especially in South America, where the night sky also holds a quite important part in the cultural heritage, and use that in my talks and in my presentation to the public to kind of try and relate science more to the, let's call them, interesting things in life. So what does that mean for our cultural heritage? What does astronomy mean for humans in general and our human inborn curiosity? So that's definitely something that I had to learn and that I'm very grateful for.
Okay, very interesting. Vanessa, maybe the next question to you. You have been working in two places, in Sutherland and in Cape Town. And we've heard that stories are important or very interesting to start a conversation. How was it in like you being in two places? How was it different to work in Sutherland and to work in Cape Town?
Well, in Cape Town, I encounter a scientific community, a family, almost, I would say, that live in around the place where they research, and yeah, we met every day at 11, right, Daniel, for the coffee. And this, I very, very quickly understood that it was very important to get to know the scientists, that after this window of opportunity, they go back to their computers, and it's a little bit more difficult to get to them. So that was the moment where I kept myself more awake, and I tried to speak as many people as I could. And then Sutherland, yeah, we organized this, well, I could join this shuttle that goes all the way from Cape Town to the desert. It's about 5 hours and a half or something like that, right? And you can see the scenery changing, and then you arrive in the middle of a desert, a rock desert that looks like Mars because it's reddish, and so, and then we were talking before about like living at night. So, and so I had to get used to this this new dynamic of sleeping during the day and being awake during the night, so I could talk to the people, to the scientists operating the telescopes, and but there were also very interesting things going on during the day, so I had to choose. So that was mainly the difference as a human being adapting to different time schedules of the profession. And obviously, like in Cape Town, the questions were touching other cultural questions and ongoing conversations, that in Sutherland was more a time for plunging or diving into the sky and being like impressed by how little human beings are and how big the questions that the scientists are asking are. And sometimes this felt super disconnected, but actually for me it was a very, very interesting scale in order to also tackle the question of post-Anthropocene, like thinking beyond human scales.
I guess it's also super interesting as the difference of the sort of bodily experience of being out there, and there's no artificial light, so it probably comes close to what also I mean, people have been experiencing for thousands of years. And Daniel, you, in your position as a science engagement astronomer, you're looking for ways to share the pertinent questions of astronomy. But you also, in the South African context, are looking at other ways and historical trajectories of observing the heavens, and how much does that influence your work and the concepts you're developing for different formats?
Yeah, thanks. I think that I think to start with, this Artisan Labs experience for me back in 2018, I was just getting going with this role, and it was a very sort of eye-opening experience. I hadn't considered having an artist in the environment, and Vanessa was wonderful at getting, you know, her hands in there and getting involved and trying to sort of really understand what was going on with the astronomy and share her insights. And I think that I said at the time basically that, you know, having someone who thought differently in an area where there's just scientists who largely think very similarly was a wonderful sort of opportunity, and something which I think has then led me into a lot of what I'm working on these days. That sort of understanding that there is a lot more that you know, humans interact with in terms of astronomy than just the science, and then that's now what the sort of primary focus of my work is, and is trying to reach people. And you know, I use the word engagement rather than outreach or anything, because all of the work we do now is to really try and engage people on a level that touches them. So whether that is through art or you know, cultural knowledge, or sort of indigenous style, or those ways of communicating astronomy and sharing astronomy are very rich and very valuable. And I think that in doing that, we reach people at a much deeper level, and that's for me, that's the goal. And I think that as soon as you've got people interested, as soon as you've got people feeling this passion for astronomy, then, you know, our field can flourish.
Okay. Maybe with this, you know, like engaging with the, or rather connecting, like engaging with society and people outside of science. I don't know how you perceive it, but I guess like there is a lot of excitement outside of the academic world in astronomy, and of course the discovery. And I guess it's, you know, like, when do we discover an Earth-like planet? Everybody's kind of excited. People are following it, like with a kind of exciting film. And of course, there's science fiction that has a lot of concepts around, and famous films from the past and also the present. And like, how much in all of this, you know, like the expectations and then your reality as researchers, how much does the outside influence the research, but also maybe the research influence then the outside perspective, or the kind of stories that then go on in a way also in society about like astronomy and astronomy research?
Yeah, well, I think that so my opinion will be different to a lot of astronomers, because I am sitting in the middle there between those two. So you know, a lot of astronomers will sort of want to just be left to their research. Less and less so, I think that, you know, more and more sort of younger astronomers are more involved on Twitter or Instagram, and you know, they want to share their excitement and their discoveries in a different way to what perhaps was done in the past. But there is obviously still a lot of research that goes on, which is very much research bound, and there isn't a feeling of sharing this. And then I think, you know, you talk about the excitement from the public. Often that excitement, it needs to get fed, and I think that needs sort of good communications coming from astronomers to share those discoveries in a way which is exciting, because, you know, we have 50 or 100 new astronomy papers coming out every day, and they're not all very exciting, but they could be if they were packaged correctly. So, you know, there's incredible research happening, and it is very exciting. And at the same time, people love astronomy. We're in a very fortunate field that people naturally love astronomy. So, you know, we already have an interest, and we have a very interesting science, but trying to make that connection is where the magic lies. And I think that there's many ways you can do that. I think the traditional ways of just, you know, a press release or something, those are useful. But I think, you know, engaging with indigenous astronomy, or, you know, art, and these different ways of engaging people it's very valuable. And I think that it just grows this interest from both sides.
I would love to kind of ask this question as well to Julia, in terms of, like, you know, like the imagery around. I mean, we see an image in your back, which is so fascinating for everybody, for me all the time. But like the science behind all this, you know, is probably not created from these kind of images. So could you maybe give like an insight on where the gap is maybe between what we understand from outside astronomy actually is, or what kind of images you're working with? And maybe afterwards, George, I would also be interested in terms of images.
So I think it's quite important to be very careful in what gets out in the public from astronomy, simply because it is so attractive, right? I mean, I can't go to the doctor or to the grocery store, and, you know, whenever I chat with somebody and they're like, oh, what do you do? I'm an astronomer, and they completely lose their minds. So and this comes with a certain responsibility, which is why I think that Daniel's job is actually probably much more important than mine, because when you talk about atmospheres, especially, so this is where, like, oh my God, is it like Earth? So there comes the problem when somebody's a little bit over eager, let's say, and starts out a press release with, we have found a super Earth with water on it, and people are like, oh, we have found a second Earth. It is amazing. The Holy Grail has been achieved. Instant Nobel Prize. This is not it. It normally means, from a scientific point of view, that we found some water vapor, so basically a hot steam bath on a planet that is somewhat like Earth, with a mass of about maybe 2 to 3 times Earth. So gravity is about 2 to 3 times as strong. There's no way we will ever live there. There's no chance in hell. So it's very important to be careful what actually gets out there, and to make very sure that these artist impressions that are very cool are actually labeled as such, because what we really get from the data is, it's basically just a graph where you see a little bit of a dip and some data points. It's not very spectacular. It's not very awe-inspiring. It's just the conclusions that you then draw from it, when they are sound and when they're verified by other scientific groups, can be quite interesting. So this is also where art has a huge responsibility towards society, to be very clear, especially when they produce these amazing, very photogenic appearances. So when you have like these drawings of exoplanets that look like pictures, but obviously they're not, because the subfield of science that is direct imaging, so we take actual photos of exoplanets, is tiny pixels on a graph that move around a little bit of a bigger pixel. So nothing like sending a probe to Jupiter where you have like astounding real life pictures. So this is a very, very important line to draw, I think. And I think this is also very important in outreach talks, to always be like, this is an artist impression. And this is why I think Daniel is so very, very important to have.
It's interesting that we have all these different roles here together in the room, because I guess what you were describing, Julia, is like also this way of communicating the science through artistic illustration or visualizations, which of course differs from what Vanessa and George would do, because they would probably not feel obliged to to just communicate the kind of image or position the research wants to show to the public, but turn it into something maybe also completely different. So I would also be interested to hear from George and or Vanessa, like what their take would be on what Julia just said.
Well, for me, I think it's an interesting one because recently Julia spent some time with my first years, and one image that she showed was the pale blue dot. Which is basically an image of what Earth looks like. And it was also in the context of trying to explain that there's quite a lot. And how we got to that conversation was specifically around this question of we found a new Earth. So for me, I don't think that's quite a problem, because as an artist who's thinking about dreams, I'm faced with the same problem. And for me, how I find myself with a camera obscura is particularly because of that discrepancy between, the data that I find in a dream and the recollection that then comes with the process of waking up and trying to articulate for myself what image I've seen. So for me, I dreamt of a water planet, but actually in reality, I dreamt of a song. A very specific song that I interpreted as a visual of a planet. So for me, I think there's a lot of productive space. There's a lot of room for error, but I think there's a lot of productive space in thinking about the distance between the data points that one finds, whether in a dream or whether with a complicated data chat that Julia speaks to. So there's a conversation there, but for me, I think it was also quite disappointing at first when I'd spent some time. There's another person that I really spent a lot of time with, Emily, who I think next time one must bring into the conversation. And like they had these posters where everybody's putting their research, and when I'm like, yes, direct imaging, and then I find an image, and I'm like, but that is not an image. It's literally, it is a pixel. And for me, that was very, very, very disappointing. And for a very long time, I didn't interact with the direct imaging guys. Because I was just like, no, guys, this is too disappointing. How can you be creating this sophisticated optical instrument and all you come up with is this? And then they talk about the CCD chips, which, like you look at them. And I'm like, how do you have this state of the art and this is what you come with? But after that disillusionment, there also came that question of, actually, no, there is a way in which as humans, we are able to, or rather as people, as visual people, we are able to make the difference. So I think it's important to have that communication that says that, look, this is an impression or this is a data point. But I think for me, there's also an argument to be made that people should actually be shown the data. Because one of the things that excite me is also just the computing power it takes for that data to be turned into an image. And for me, those type of conversations are interesting. And have led to, the question of the server ultimately comes because I'm aware, I'm interested in a server and I'm trying to make a server. I've procured a server. For me also speaks to that question of the algorithm. What other types of images do scientists make, and how do people get used to seeing those images? I'm going to stop. I've gone too far. But for me, it's important to think about, the correct image, which is exciting, and you need the excitement because otherwise people wouldn't follow astronomy. But for me, it's not a problem that plagues only astronomy. But for me, as a person that has to contemplate what an image is, I had the same problem because the camera obscura is a direct result that I couldn't make a film because the type of image that a film would make would not be an accurate representation of the dream that I was trying to replicate. So for me, there's a way in which the camera obscura fascination is also about a failure for our current imaging technologies as artists to adequately portray or visualize an idea that I had in the dreamscape. So it's a problem that I think we have to think about.
Yeah. And now moving away from the image to Vanessa, because you were choosing to work with noise. So what is the connection there?
I pick on what George said about give the people the data, and because I've worked with different scientists in the recent years, and I was always shown the beautiful pictures, either the microscopic pictures or the macroscopic pictures. And whenever I ask for the data, I encounter the friction. Because of many other connecting issues like access and the competition that there is inside the academia, and also inside the art world. Every area of knowledge has these two urgent questions to talk about. And I guess that also I wanted to not only like give people the data, and then I will go to the noise question, which is like the reason why I choose noise. Give the people the data or the non-scientist data to see what we can create with. And also, and by the way, I was very, very thankful that I didn't have any problem at all while I was doing my research at the SAAO to access tons and kilometers of data. And to do whatever I wanted to with that, but in other contexts, I had the frictions when I asked for that, because that is what we mine or they mine while doing the research. The other question is, or the other point is, the technology is not neutral.
Vanessa, can you hear us? I think she is gone for the moment.
Knowledge that they exist and how they work. And yeah.
Can you repeat the last sentence, because you were the image froze? And technology is not neutral, and then?
Yeah, and the tools that we use, the technological apparatus, it's important that we know how it works and what it works for. And when we have an algorithm and we make meaning of this algorithm, we choose the hypothesis, we choose the variables, we choose what to pick and what to discriminate, and therefore we make the meaning according to that. And so having artists or people that are questioning those algorithms or variables and how the meaning is made, it's important. And to have this public event so more people know about it, it's very important, because we can question all the questions about the tools that are used and how the meaning is made. And basically that's why I choose noise, because noise is a new language. It can be it's a language that can be speculative, to say something that is not said. And in my case, I I started in a very naive way, the research about asteroids and how to connect with my own research. And I remember hearing a story about like this incredible alarm system to track asteroids. It's something like, I think it's extremely important for our own survival, right? We don't want to get hit by an asteroid and kaboom, the life is done on Earth as we know it. But through this data, we can also know what kind of minerals this asteroid carry, if they carry water or if they carry gold. And I heard that I'm talking about speculative design and speculative objects and speculative language, but I hear about these two companies that are starting to develop technologies to wrap asteroids up in order to melt the water that they carry. So maybe we don't need to carry so much water when we launch a spaceship. And other companies that were wondering, if I characterize this meteorite first and I arrive first, but on the way there is another company that arrives before me, because I don't know who owns the asteroid, right? To exploit the minerals or the resources. So I think we should be able to enter these discussions as society. And for me, art is a way to do it, more than represent the data through different mediums, visual or audiovisual, but to create languages to talk about, in this case, an asteroid as an agent that has agency, that has memories, that is a territory, that is a planet that carries life and can be also a place to explore in another way. It can be a proxy of some issues that we have on Earth. And it can be also a place to dream about other ways to think about matter. Yeah, I will leave it there.
Mm-hmm. Yeah, thank you very much.
If I can say something.
Sorry?
No. I want to pick up something, because
okay.
This idea of give people the data, for me has it's got many implications. But for me, what is also curious for me would be, we always assume that people might not be able to read the data. And for me, I'm always curious about, like, I don't know, as an artist, there's a way in which I have a sensitivity to form in many ways. And I'm curious about, if one was to have, or rather if the data was to be made more freely accessible to everybody, what kind of languages would we develop for interpreting that data? I mean, it's a thought that's just come in. I haven't really thought about it, but for me, there's something interesting about what it would mean for people getting used to seeing raw data, and what that would mean for our capacity to develop algorithms for wading through that data. It's just a side note.
Thank you, George. I'm looking at the clock or watch or digitals, and we are already over the time, actually. But I would really like to ask the people that are still in the room if there's any questions. That would be just about like the last chance for today, to any of the artists or scientists or us. And if not, is there anything from the panelists that you would like to share with us, like as a last kind of wrap-up thought before we close the session?
I know a space pilot.
Or, sorry?
I know a space pilot.
The space pilot. Come on, Nicolas. Space pilot. Yeah.
When there's questions from, there's question from Dinero, where she's asking, what do the astronomers dream about?
Oh, nice. Yeah. What a nice question. Thank you.
Well, I mean, since you're asking and my mic seems to be open, I mean, just last night I dreamt about cats and kittens, and this is what I told my little girl. So, you know, to some extent, I think just astronomers are like normal human beings, you know. It's just our work gets us to, you know, different territories, but otherwise, most of us, I think, are still, you know, the foot on the ground, I would say, and keep a little bit of like a, you know, we need to be a bit nuts and, you know, a little crazy at times, but most of the time we have to have the foot on the ground.
And what can I just add? And what is the dream, like the dream, not the night dream, but about chaos, which is your tool?
A dream about chaos, like something that could happen with chaos. That's that it keeps going forever. That's, yeah. And that it makes like, you know, little babies, you know, so that like we have like many chaos and like, you know, people would be happy and yeah.
Like the kittens.
Yeah, exactly.
Okay. Julia.
Well, so recently actually, and I was very close to writing George because I think he would have loved this. So this is where you see also the hard reality of science, right? Because it's not only, I mean, a lot of it is looking at the night sky, which is obviously amazing, but a lot of it is also like the churning and the slow crawl towards knowledge that has to be peer reviewed, that has to go through a very rigorous process that we can't just publish what we want, right? There's no artistic liberty in science in this regard, in the data quality regard. And one of my papers got recently stalled in this process, right? So for many months, I was just like providing more data, providing more explanations, trying to convince the people to please publish my paper. And then I dreamt, I come from the Alps. I'm German, I'm not Swiss, but I do come from the Alpine regions. And I dreamt that the peer reviewer was anonymous. I was chasing this anonymous person that was giving me critiques about my paper on a sled down a mountain. It's very satisfying, to be honest. so that was great. But apart from this intersection of let's call it frustration in the workplace with normal life, there's also this constant dream of thinking about what could possibly be out there. Right, so you write these proposals, you get this observation time, but you never know what you get in the end, because we can't construct experiments, we can't build anything. Basically, we just observe what is already there. We're basically just taking pictures in the largest of senses, and then hope that something interesting happens. And so there's always this dream, like there's always this moment of suspense when you look for the first time at data, and either it's super interesting directly, or there's like this question mark of what am I looking at, which is normally the really interesting stuff. So there's always this moment of suspense, which is kind of what I live for. So I love the night sky and everything, but like this opening of the black box for the first time, that's very, very exciting.
It sounds very exciting.
Yeah,
so sorry, no. Yeah.
No, I just meant to say that this is so very true. I mean, like the thrill that you get, you know, I mean, if you're the first person to see something that nobody saw before, I mean, this thrill, this does not happen very often, but when it does, yeah, that's quite satisfying. Yeah, it's true.
Daniel, last but not least.
What do I dream about? I mean, when I'm awake, I dream a lot of things about astronomy and solving the questions. At night, I'm one of those odd people who, for whatever reason, has remembered about 3 dreams in my life.
That'll be good.
So it's not clear to me whether I do dream. So maybe that's the right answer.
Sorry, I forgot. So and And what is the dream like at the SAAO of like also, you know, in terms of future projects?
I think that the dream I'd like to see in the next 20 or 30 years in South Africa is a South African Nobel Prize winner. I think that we have the instrumentation, we have the telescopes, we've got the skies. Projects like the SKA are coming, and I think that that's an achievable goal. So.
Great. We're looking forward to that.
Mm.
So I think now we wrap up. I don't see another question. And I would really like to thank everybody for their engagement, for everybody to stay, the audience in a way. And I would like to give Sinetemba the continuation of all this.
Thank you everyone for joining us. Please do join us again on the 30th of July, where we will be having a collective listening experience as part of Vanessa's project, Always Calling Home. Sanele Ngubane, who is a sound artist and DJ, will be presenting a set titled Space Rock Noise. And this will be within the virtual environment that Vanessa has created for the project. Okay, thank you everyone.
Thank you very much.
Thank you, everybody.
Thank you to the panelists.
Thank you.
Ciao, ciao.
Thanks a lot. Bye.
Nice evening.
Bye-bye, everybody.
Thank you.